Hello friends, I welcome you all to my channel. I hope you're all well and your studies are also going on well. So this is the last part of the chapter on factorization, part 4, where I will address a few concepts that is not given in the textbook of author R.S. Aggarwal, but I have found these concepts to be important, and based on these concepts, problems are asked in some competitive examinations. So these concepts are common factors, irreducible factors, and irreducible form of an algebraic expression. So this video is part of the playlist CBSE Maths for Class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I am in a different setup. I'm in now in Windows operating system, and I'm using a different writing software, because in the previous earlier I used to record in a very old Mac which whose configuration was very bad, and it was giving a lot of problem while writing, while discussing and writing on the software. So this will be a new experience for me to work in the Windows operating system and with a new writing software. I don't know how it will go. Let's see how it goes. Hopefully this Windows machine has a little better configuration. I hope it will go well. Okay, so let's start. So I will discuss about three major concepts. First one is the common factors of terms or expressions. So this chapter is about factorization, that is factorizing a given algebraic expression into two or more factors. So we express algebraic expression as a product of two or more factors. Now, what is a common factors of terms or expression? I will try to explain the concept with examples. So let's say we have terms like minus 5 x square, comma, let's say 20 x x square y, and let's say minus x cube minus x cube. Now, what will be the common factor of these three terms? The common factor now I'm writing, I will use some short form. Let's use the short form CF, that is common factor. CF means common factor. The common factor will be equal to x square, why? It is similar to the highest common factor. It is similar to HCF of some natural numbers. Some natural numbers. So this so common factors is x cube. Now why it is the common factor is x square. Why it is x square? Because we see that x, the literal variable, the variable or the literal variable or the algebraic variable x is occurring in all the terms, and the and the minimum power of that variable x in all the terms is 2, because the first two terms the power of x is square, and for the third term the power is x cube, 3. So the minimum of 2 to 3 is 2. So the power will be x square. This is the common factor of the terms. The x is not a common factor. X is not a common factor. Just like if we have, let's say, 4, 6, 4, let's say 4, 12, and let's say 28. The HCF of 4, 12, and 28 is equal to 4. That is the highest common factor. So the common factor of some terms or even expressions, if 2 or 3 expressions have any common factor, then also we use the term common factor. Let's say, so this was for common factor of few terms. Let's say, let's take another example. Let me quickly check if everything is visible properly or not. Okay, let's take another example. Let's say we have minus 3 x cube y square z, and let's say 6 x to the power 4 y z z cube, and let's say minus 9 x to the power 5, and let's say y cube, and let's say z to the power 4. So what will be the common factor of these three terms? First of all, you have to consider all the numerical coefficients of the terms, and the numerical coefficient of the common factor will be the HCF of the numerical factors of all the terms. The numerical factors of the terms are minus 3, 6. The numerical coefficient of these three terms are minus 3, 6, and 9. So what is the HCF? HCF of minus 3. Let's ignore the sign. While taking in finding the common factor, numerical coefficient of the common factor, you must ignore the sign of the numerical coefficients of the terms. So let's say, what is the HCF of 3, 6, and 9? This is 3. So the coefficient, the numerical coefficient, or the coefficient, it means the same, of the common factor will be 3. Now let's see what will be the variables. Now the variable x occurs in all the three terms. In the first term it is x cube, in the second term it is x to the power 4, and in the third term it is x to the power 5. The minimum power is 3, so we will have x to the power 3. For the variable y, it also occurs in all the three terms. In the first term, the variable y is occurring as y square. In the second term, it is y, and in the third term, it is y cube. So the minimum power is 1. So we will have y. Similarly, for z, we have z cube, and z to the power 4, and the minimum power of z is 1. So we will have z. So this is the common factor. This is the common factor of the these three terms. So this is how we find the common factors of some terms. Like if you have an expression of 2 or more 3 terms, if you want to find the common factor, this is how you find the common factor. Now this also applies, common factor also applies in finding out we also find the scrolling is giving problem. We also find a common factor of expressions. Let's say we have let's say we have an expression. Let's say okay, so I was explaining common factor. Okay, I am explaining common factor. Okay, fine. Let's say what will be the common factor of, let's say we have an expression like 3x multiplied by x plus x plus 1 square minus, let's say, 4x square. I'm just creating some random expression. It may not make any sense. Anyway, so let's say we have an expression like this. We can clearly see that this part you can consider as a not term actually, but let's say this part is having is in the form 3x multiplied by x plus 1 whole square. So it has x plus 1, and this part also has x plus 1. I want to figure out, I want to find what is the common factor between these two parts, between these two parts, so that I can factorize. So I can clearly see that the first part is having x plus 1 square, and the second part is having x plus 1 cube. Also, we are having 3x and 4x cube. So the common factor of these two parts, if we factorize it, it will be 3 and 4. 3 and 4, their HCF is 1. So we do not write 1 as a product. If 1 is a factor, we do not write it. So then we have x and x square. So from the x and x square, the variable x occurs in both the parts, and the minimum power of x is 1. So we will have x, and we can see that x plus 1, the factor x plus 1 occurs in both the parts. In the first part, we are having x plus 1 square, and in the second part, we are having x plus 1 cube. So the minimum power is square. So we will have x plus 1 square. So this is the common factor of the algebraic expression that I have written. Now you will have 3 minus 4x and x plus 1. So this is the factorization. So this was the common factor in these algebraic expressions, which is, you can consider the algebraic expression has been written as two parts. That is, first part is the 3x multiplied by x plus 1 whole square, and the second part is minus 4x square multiplied by x plus 1 cube. So the common factor also works for an algebraic expression. So it works for a few terms, it works for terms, and it also works for algebraic expressions. Okay, so this was common factors. So this is very important to understand, because these are very fundamentals in the factorization of algebraic expressions and creating factors. Okay, now what is irreducible factors of an expression? Irreducible factors of an expression. Irreducible factors of an expression is like expressing a natural number as its prime factors. So we know, let's first understand how do we express a natural number as a prime factors. I mean, how do we do prime factorization of a natural number? Let's say I have a number 6. So the prime factorization of the 6 is 2 into 3. That is, we express 6 as a product of prime numbers, and we know that prime numbers cannot be further broken down as product of any other numbers. Similarly, let's say 12, the prime factorization is 2 into 2 into 3. So all the individual, so these are the individual factors. In the prime factorization of 6, 2 and 3 are the individual factors, and they are prime numbers. For natural numbers, the individual factors are prime numbers. For 12, it was 2, 2 and 3. Let's say 21. So this is equal to 3 into 7. Let's say 42. 42 is 6 into 7. Now 6 into 7 is not the prime factorization of 42, but the prime factorization of 42 will be, because 7 is a prime number, that is fine, but 6 is not a prime number. We have to further factorize 6. So it will be 2 multiplied by 3 multiplied by 7. So I hope you already know what is the prime factorization of a natural number. Just for the sake of discussion, I am discussing it. So this is how we express a natural number as a product of its prime factors. The concept is same for irreducible factors of an expression. Let's say I have an expression. Let's say let's say I have an expression which is a constant term 4, let's say. So let's go by example. Let's say 4. This is an algebraic expression. Of course, this is an algebraic expression containing a single term, and that term is a constant term 4. Now, is this it's a single term, so is this in irreducible? Is this in okay? Let's we are discussing irreducible factors. Irreducible factors. Okay, so let's consider. Okay, fine. This is fine. So 4. Now 4 is not an irreducible factors. Why? This is a term. This is a constant term. It is not in irreducible. It is not an irreducible factors. Why? Because we can further factor 4 into as 2 into 2. 2 into 2. So this is irreducible factors. I am in short writing. Let's call this as IIF. That is irreducible factors. So this is irreducible factors because we have expressed 4 as a product of 2 and 2. That is a product of 2 and 2, and 2 and 2 are individual factors, and they cannot be broken down into they cannot be expressed. 2 cannot be expressed as the product of 2 or more numbers. So this was so if the constant term is a natural number, then of course it will be considered as an irreducible factor if it is in if either it is a prime number or it is written as a product of prime factors. Now, okay, so similarly 6 is not an irreducible factor. For example, if you have 6 is not an irreducible factor because we can further we can further express 6 as product of 2 into 3. So this form, that is 2 multiplied by 3, this is irreducible factor. So this was a very simple example where it is a constant term. Let's say 4x. Is this irreducible factor? No, it is not an irreducible factor because we can further create factors from 4x. That is, we can write 4 as 4 into x. Now this is also not irreducible factor because we can further create factors from 4. So 4 can be written as 2 into 2 into x. So this is the irreducible factor. The 4x, it is a factor. I mean 4x, let's say we have a expression 4x multiplied by x plus 1. So in general we say that 4x is a factor and x plus 1 is a factor. But yes, 4x is a factor and x plus 1 is also a factor, but 4x is not a irreducible factor because 4x can be further expressed as 4 into x, and 4 into x. This also is not this is also not a irreducible factor because 4 can also be further expressed as 2 into 2. Now 2 into 2 into x, this is an irreducible factor. Irreducible the 4x, the factor 4x, it's irreducible when it is expressed as an irreducible factor. It will be written as 2 into 2 into x. So that is the concept. So let's take another example. Let's say minus 12. Let's say minus 12 x square. This is not a this is a factor. Of course, this might be a factor of some algebraic expression, but this is not a irreducible factor because we can further break down, because we can further express minus 12 x square as a product of some factors. That is, we can obviously write minus 12 into x square. This also is not in this also is not a irreducible factor because this can further be written as minus 4. Let's say minus 4. I'm ignoring the multiplication sign. I hope you will understand. We can express these minus 12 as minus 4 into 3, and we have x square. This minus 4 product of minus 4, 3 and x square. This also is not in the factor minus 12 x square. If we write it as minus 4 into 3 into x square, this is also not an irreducible factor, because we can write further as minus 1, let's say minus 1, and 4 can be written as 2 multiplied by 2, and we have 3, and x square can be written as x and x. Now you can consider this as minus 1 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by x multiplied by x. Now this is an irreducible factor. That is, when you write minus 12 x square as an irreducible factor, you have to write this way. That is minus 1 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by x multiplied by x. Let's take another example. Let's say we have 9 x square y z. So definitely this factor, if this is a factor of some algebraic expression, this factor is not an irreducible factor, because the irreducible factor, now I am directly writing the irreducible form of the factor. So this will be, let's say, minus 1 multiplied by 9 is 3 into 3, and then x square has to be written as x multiplied by x, and we have y multiplied by y. So this is the irreducible. This is an irreducible factor, because if you consider any factor in this form, it cannot be further broken down as a product of 2 or more further factors. So this is an irreducible factor. I hope you got. I hope the concept is clear. What is meant by an irreducible factor? So if you have an algebraic expression, let's say x cube y multiplied by, let's say, z minus 1. Let's say this is an algebraic expression, and it has been written, it has been factorized as x cube y and multiplied by z minus 1. Now you can say, it is very correct to say that x cube y is a factor of the algebraic expression, and also z minus 1 is a factor of algebraic expression. But x cube y is not an irreducible factor, whereas z minus 1 is an irreducible factor, because you cannot express z minus 1 as product of 2 or more factors. Okay, but x cube y, the factor x cube y is not an irreducible factor, because so this can be further written as x multiplied by x multiplied by x multiplied by y. So this entire algebraic expressions can be written as x multiplied by x multiplied by x multiplied by y multiplied by z minus 1. Now I can say that y is an irreducible factor of this algebraic expression. I can also say z minus 1 is an irreducible factor of this algebraic expression. Also, x is an irreducible factor of this algebraic expression. But you cannot say that x square or xy or x cube or x cube y or even y into z minus 1 is an irreducible factor of this expression. So the basic concept is that if you have a factor, if you cannot factorize a given factor further into 2 or more factors, then that factor is an irreducible factor. Okay, so this was irreducible factor, concept of irreducible factor, common factor, and let's now finally understand what is irreducible form of an algebraic expression. What do we mean by, the scrolling is what do we mean when we say that a given algebraic expression is in irreducible form? Consider this: 4 into no, let's say a square minus b square. This is an algebraic expression. Is this algebraic expression in this algebraic expression in irreducible form? No, because we can further factorize this algebraic expression into more factors. That is, from the identity we know this can be written as a minus b multiplied by a plus b. Now we can say that a minus b into a plus b, this is an irreducible form of the expression a square minus b square, because all the factors in this form are irreducible factors. So what is an expression in irreducible form? That is, this basically is an expression expressed as product of irreducible factors. Then that form of the expression will be known as then the expression will be said to be in irreducible form. So a minus b multiplied by a plus b, this is an irreducible form of the algebraic expression a square minus b square. Let's take another example. Let's say 4x multiplied by, let's say 4x multiplied by y plus 2. Is this algebraic expression in irreducible form? No, because if you write it, because we can see it is no, because the factor y plus 2 is an irreducible factor. That is fine, but 4x is not an irreducible factor. So the irreducible form of this algebraic expression will be 2 multiplied by x multiplied by y plus 2. Now this is so the irreducible form of this algebraic expression is this: irreducible form of 4x multiplied by y plus 2. Okay, let's take another example. Let's say minus 2x plus 12 x square y. So this is an algebraic expression. Is this in irreducible form? No. First of all, if you are given an algebraic expression, if you can factorize that algebraic expression further, then of course the given algebraic expression is not in irreducible form. So an algebraic expression will only be in irreducible form only when it has already been expressed as a product of some factors, and all the factors are irreducible factors. So this algebraic expression. First of all, we see that we can see that there will be a common factor from the two terms. So definitely this algebraic expression is not in irreducible form. So let's try to express this algebraic expression in irreducible form. First let factor out the common factor. So the common factor will be 2x, because the variable x is occurring in both the terms, and the minimum power of x is 1. Also 2 is the HCF of the numerical coefficients of both the terms. So we will have 2x as the common factor, and then we are left with minus 1 plus 6xy. You can consider it as 6xy minus 1. Now, is this form? Is this form in irreducible form? Is this now is this in irreducible form? No, because this factor is an irreducible factor, but this is not 2x is not an irreducible factor. We have to express 2x as 2 multiplied by x multiplied by 6xy minus y. Now this whole is now in irreducible form. This is the irreducible form of minus 2x plus 12x square y. I hope by now you have got the idea, you have got the concept, what is meant by an algebraic expression in irreducible form. Let's take another example. Let's say an algebraic expression has been factorized as minus, let's say, minus x square y, let's say z square minus 4. So this let's say so this is the, let's say this is the factorized form of an algebraic expression. Now can we say that this is in the algebraic expression is in this algebraic expression is in irreducible form? No, because we can further factorize the factor z square minus 4 is not an irreducible factor, because we know that it is of the form a square minus b square, and we can further factor it express z square minus 4 as z minus 2 multiplied by z plus 2, and also x square y is also not an irreducible factor. We can further create factors from x square y. So the irreducible form, so whatever this algebraic expression is, the irreducible form will be minus, let's say minus 1 multiplied by, that is x square. So we will have x multiplied by x, we have y, and then we will factorize z square minus 4 as z minus 2 and z plus 2. Now this form is irreducible form. This is an irreducible form. Irreducible form of minus x square y z square minus 4. I hope my writings are readable. Because I am using a different software, I am not really having a good control with my pen and the way the software is working. I hope my writings are readable. Okay, so this is the irreducible form of the factorized algebraic expression, because now you can see all the factors are irreducible factors. Z plus 2 is an irreducible factor because you cannot further express that as product of 2 or more factors. Z minus 2 is also an irreducible factor. Similarly, y, x and minus 1 are also irreducible factor. Let me end up this video by giving an last example of irreducible form of an algebraic expression. So let's say we have an algebraic expression x square minus 2xy plus y square, and we have, let's say, plus 4x minus 4y. Given so this is an algebraic expression, and we are asked to, let's say, we are asked to express this algebraic expression in irreducible form. In irreducible form, how do we do it? So first of all, we will first try to factorize it. We will first try to factorize it as we do normal factorization. So clearly we can see that this is an x minus y whole square, and also we can so you can create group. From the first three terms you can create a group, and from the last two terms you can create a group. So from the first group, we know that it is of the form a square plus b square minus twice ab, which is equal to, as per the identity, a minus b whole square. So this becomes x minus y whole square. And from the second group, I can take from the terms 4x minus 4y, I can take 4 as a common factor, and this will be 4 multiplied by x minus y. So now it is not yet factorized. Now we see that from here, from this part and from this part, we have a common factor of x minus y. So we will take out that factor, and we will be left with x minus y plus 4. X minus y plus 4. So the final factorization becomes x minus y multiplied by x minus y plus 4. Now this is an irreducible form of the given of the expression. This is irreducible form because we are having two factors. X minus y cannot be further broken down as a product of two or more factors, as well as x minus y plus 4 can also be not broken down into further two or more products. So this form x minus y multiplied by x minus y plus 4 is the irreducible form of this algebraic expression. I hope I was able to explain properly what is the three concepts, that is the common factors of some terms, or how to find the common factors from the terms of an algebraic expression, or even find the common terms between two or three algebraic expressions. And then what is an irreducible factor? What is an irreducible factor? Whether if you are given an algebraic expressions as in the factorized form, and if you are asked among all the factors, which one is the irreducible factor of the algebraic expression? So let's say you are given a factorized algebraic expression. Let's say minus x multiplied by let's say 2x minus 4, and let's say z square minus 1. So this is a factorized form of an algebraic expression, and you are asked what will be the what is the irreducible factor of this algebraic expression. Clearly the answer will be, let's ignore the negative sign. Let's say this is the algebraic expression in the factorized form, and you are asked what is the irreducible factor of this algebraic expression. The answer will be x. Why? Because the factor 2x minus 4 is not a irreducible factor, because this can be further expressed as 2 multiplied by x minus 2. So 2x minus 4, since it can be further expressed as product of two or more factors, it is not a irreducible factor. Similarly, these two factors are not irreducible factors, as z square minus 1 is equal to z minus 1 multiplied by z plus 1. So the irreducible factor of this algebraic expression is x. So similarly, if you have, let's say 2x minus 1 multiplied by, let's say 4x square y, obviously in this expression the irreducible factor okay, so if you are asked for this algebraic expression what are the irreducible factors, what are the irreducible factors? The irreducible factors will be 2x minus 1, because you cannot factor it you cannot create a factor, express 2x minus 1 as a factor of, as a product of two or more factors. Also, you will have 2, because 4 will be in the irreducible form of this expression. This is, if you express this algebraic expression in irreducible form, this will be 2x minus 1 multiplied by 2 multiplied by 2 multiplied by x multiplied by x multiplied by y. So the irreducible factors of this algebraic expression will be 2x minus 1 comma 2 comma x comma y. So I will end the video here. I hope this video was beneficial in clarifying the concept of common factors, irreducible factors, and an algebraic expression in irreducible form. If you find this video beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So this was probably the last theoretical video on the chapter of factorization, and I also watch out the other playlist, that is Maths 8 Hard, where I solve little harder problems on every chapter as and when they are completed in the playlist CBSE Maths 8 RS Aggarwal, and those problems are based on problems that came in competitive examinations, and some problems are also framed by me, and the problems that are framed by me, they are of course inspired by the pattern of the questions that come in that are given in the NCERT exemplar textbook or in some competitive examinations. So always try to solve those problems. If you can solve those problems yourself, that is fine, and if you cannot, you can see my solution video. Thanks for watching, and until the next video, take care and bye.